unknown type of time and radioactive decay, unstable nuclei of radioisotope becomes stable, permitting charged particle and energy. The process is called radioactive decay. It is a nuclear as opposed to chemical reaction in which one element changes to another. Types of radiation decay. There are three types of radiation decay: alpha, beta, and gamma decay. All three types nuclei emit radiation, but the nature of that radiation differs from one type of decay to another. What is the alpha decay? Alpha decay occurs when an unstable nucleus emits alpha particle and energy. Alpha decay. Alpha particle contain 2 protons and 2 neutrons, giving a charge of +2. Helium nucleus has 2 protons and 2 neutrons. The alpha particle is represented by the nuclear equation by the symbol 42He. Superscript 4 is the mass number, 2 protons plus 2 neutrons. Subscript 2 is the change of charge of particle, as well as the number of protons. Example of alpha decay is decay of uranium-238 to cerium-234. This reaction, uranium loses 2 protons and 2 neutrons to become the element thorium. The reaction can be represented by the equation U238 and 92 to Th234 90 plus 42 plus energy. To count the number of protons and neutrons on each side of the equation, you'll see that number are the same on both sides of the arrow. This means that the equations are balanced. Thorium-234 produces this reaction is unstable, so it undergoes radioactive decay as well. Of a particle produced in the reaction can pick up 2 electrons to form the element helium. That's how most of Earth's helium are formed. What is beta decay? Beta decay occurs when unstable nucleus emits beta particle and energy. Beta particle is an electron have charge of -1. In the nuclear equation, beta particle is represented by the symbol E. The subscript -1 represents the particle's charge, and the subscript 0 shows that particle have virtually no mass. Nuclei contain only protons and neutrons. How can nucleus emit an electron? Neutron first breaks down the proton and electron, then the electron is emitted from the nucleus, while the proton stays inside the nucleus. Proton increases the atomic number by 1, thus changing one element into another. Example of beta decay is the decay of thorium-234 to protactinium-234. In this reaction, thorium loses a neutron and gains a proton, become protactinium. The reaction can be represented by the equation Th234 90 to Pa234 91 plus E01 -1 plus energy. The protactinium-234 produced in this reaction is reactive and decays to another element. Electron produced in the reaction plus with another electron can combine with the alpha particle to form helium. By decay, an electron and a proton form neutron. Another unusual particle called neutron is also produced. An electron emitted from the nucleus. After they exchange the atomic number and the atomic mass of the atom. What is gamma decay? In alpha and beta decay, both particle and energy are emitted. In gamma decay, only energy is emitted. Gamma decay occurs when unstable nucleus give off gamma rays. Gamma rays, the rays of visible light, and X-rays with energy travels through space at the speed of light. Gamma rays have the greatest amount of energy, such as all waves. By itself, gamma decay doesn't cause one element to change into another, but it's released nuclear reaction that do. Some of the energy released in alpha and beta decay in the form of gamma rays. Comparing the types of radiation of a particle can only travel a few centimeters to the air. They cannot pass through a sheet of paper or thin layer of clothing. They may burn the skin, but cannot penetrate tissues beneath the skin. Beta particle can travel out 2 meters through the air. It can pass through paper and clothes, but not through a sheet of aluminum. They can penetrate and damage tissue beneath the skin. Gamma rays can travel thousands of meters through the air. They can pass through a sheet of luminance as well as paper and clothes. They can be stopped only by 10 centimeters of lead, centimeters of concrete, can penetrate and damage organisms deep inside the body with the rate of radioactive decay. Radioactive isotope decay has a certain constant rate. The rate is measured in a unit called half-life. This is the length of time it takes for have a given amount of this isotope to decay. The half-life of this radioisotope is 14 days. After 14 days, the half of the original amount of phosphorus 32 had been decayed. After another 14 days, half the remaining amount or 1/4 of the original amount has decayed, and so on. Different radioactive isotope regulating their rate of decay, as the half-life of radioactive isotope can be as short as a split second, long as 7 billion years. For example, half-life of isotope uranium 238 is 4.4 billion years. Half-life isotope potassium 40 is 1.28 billion years. Half-life of isotope carbon-14 is 5,730 years. Half-life of isotope hydrogen 3 is 12.2 years. Half-life of isotope radon 22 is 3.82 years. Half-life of isotope polonium 214 is 0.00016 seconds. What is radioactive dating? Radioactive isotope can be used to estimate the age of fossils and rocks. Method called radioactive dating. Carbon-14 dating is an example of radioactive dating. How carbon-14 dating works. Carbon-14 forms naturally in Earth's atmosphere when cosmic rays strike an atom of nitrogen-14 living things, taking and use carbon-14 just as do carbon-12. Carbon-14 living things gradually decays to nitrogen-14, and when it is constantly replaced because the living things keep taking carbon-14. As a result, there are fixed ratio of carbon-14 to carbon-12 in one organism as long as they are alive. After organisms die, carbon-14 already contained continue to decay, but is no longer replaced. For carbon-14, the organism constantly declines at a fixed rate equal to the half-life of carbon-14. Have the remaining carbon-14 decay every 5,730 years. If you measure how much carbon-14 is left in the fossil, you can determine how many half-lives and how many years have passed since the organism died. Was a limit on carbon-14 dating. Carbon-14 have a relatively short life after about 50,000 years. Too little carbon-14 is left in some fossil to be measured. For carbon-14 dating can be used to date fossils that are less than 50,000 years old. Radioisotope with a longer half-life, such as potassium-40, must be used to date older fossils and rocks. That makes summary. Radioactive decay is the process in which unstable nuclei become stable by emitting particle and energy changed into a different element. There are 3 types of radioactive decay: alpha, beta, and gamma decay. Each differing from what is emitted. How far it can travel, what it can penetrate. Rate of radioactive decay vary from one radioisotope to another. The rate is measured by the half-life. This is the length of time takes half the amount of radioisotope decay. Radioactive dating is the use of radioactive decay to estimate the ages of fossils and rocks. An example is carbon-14 dating. That's all. Thank you very much.